Hello and welcome back to the MoDyPy Basics tutorial series. In this tutorial, I will show you how to model this simple pendulum with interdependent states in MoDyPy. If you are the kind of person who rather reads tutorials instead of watching them, hop over to docs.modypy.org where you will find this tutorial series in text form. In this tutorial, we will model this mathematical pendulum. We have a mass that is fixed to a fixture by a string. And we do know the length of the string, and the mass of the ball is irrelevant, as we will see. Now we want to describe the dynamics of the deflection angle alpha. And to do that, we first have to look at the forces working on the mass. There is the gravitational force and there is a force along the string. And if we add those together, we see that a little bit of force remains here that is working perpendicular to the string. And to get the amount of that force, we look at the amount of the gravitational force and some trigonometry here. So we see the gravitational force is mass times gravitational acceleration, and the moment acting on the ball here is this gravitational force times the length of the arm times the sine of the deflection angle alpha. And if we use this to get some equations of motion, we get the acceleration, or the time derivative of the angular velocity, to be minus g over L times the sine of the deflection angle. So here we already have our first state. And of course, we also define an initial value for that state. The second state is the state that we're actually interested in, and that is the deflection angle. And the derivative of that deflection angle is simply angular velocity. So we see we have a cross dependency here. So the derivative of alpha depends on omega, and the derivative of omega depends on alpha. And we will see now how to deal with that in code. I have already prepared some of the code. So I added imports for NumPy and Matplotlib, and for some basic elements of MoDyPy. We will need the system class and the state class, and later on we will need our simulator and the simulation result. I also defined some system parameters. Here we have the length of the string and we have the gravitational constant. You see that we're working in the SI system, so we're working with meters and seconds as units. We also have some initial conditions for the two states. We have alpha naught equal 10 degrees. So we deflect the pendulum in the beginning by 10 degrees. And we have omega naught equal 0. So we don't give it any push before dropping it. And now we want to define our pendulum system. First, we need our system object. And then we define our two states. The first state is omega, the angular velocity, and it is part of the pendulum system. Its derivative function is a function we still have to write, and it's omega dt, and its initial value is omega naught. And for alpha, we do the same. Only that the derivative function here is simply omega. We can use the state as a derivative function because it is callable and it follows the protocol that most of the functions in MoDyPy follow, which accept a single system state object. The initial condition here is alpha naught. Now we need to define the derivative function. So we define omega dt, and as I said, it accepts a single system state object. And we have to calculate the value of the derivative. And that is minus gravity divided by length times the sine of the state alpha. And we can refer to alpha here already because the so-called closure of functions in Python includes any variables and objects declared on the containing level. So the objects declared after the function definition are known within the function. However, the same is not true vice versa. So if we were to move the function definition below the state definitions, we would get an error here because omega dt is not yet known. So we'll keep it above here. And that is already all for our system definition. And now we want to do a little bit of simulation. So we create our simulator. And I will already set the step size to 0.1 seconds. We get our result object and we collect our results from the simulator. And now we can plot those results. We will simply plot the angle alpha against time. And here we see quite a nice sine wave appearing. And it also has a period of about 2 seconds, which corresponds with the theoretical results. So that is already all for this tutorial. We have seen how to deal with interdependent states. And also we have seen how to work with multiple states in a system. So that's it for this tutorial. There's still lots to come, so stay tuned and I hope to see you back soon.